The check engine light glows on your dashboard. You plug a scanner into the port under the steering wheel. The screen displays a code, P0175. The description, System too rich, Bank 2. For many drivers, that triggers confusion and anxiety. A common reaction is to start buying parts. People often rush to replace oxygen sensors, spark plugs, fuel injectors. This is called the parts cannon, expensive and inefficient. The check engine light often stays on anyway. Hundreds of dollars spent. Problem still there. P0175 is not a command to replace a part. It's a data-driven message from your car's brain, the ECM. The ECM monitors air-fuel mixture using oxygen sensors in the exhaust. The code means too much fuel, not enough air, coming from Bank 2. Bank 2. The side without cylinder 1. The ECM reduces fuel to compensate. That correction is called fuel trim. If fuel trim hits its limit and can't fix it, the ECM sets P0175. To properly diagnose P0175, you must first understand what a rich condition is. An internal combustion engine ignites a precise air-fuel mixture. The ideal stoichiometric ratio is about 14.7 to 1. A rich mixture has too much fuel or too little air. It might be 12 to 1 or even lower. That imbalance means not all fuel burns. Unburned fuel exits the cylinder and goes into the exhaust where oxygen sensors detect it. Two fundamental failure types cause rich conditions. Type 1. Too much fuel delivered to the cylinders. Fuel injector stuck open or leaking. Fuel pressure regulator failure causing high fuel rail pressure. Faulty command from the engine computer. Type 2. The computer thinks there's more air than actually present. That incorrect info causes the computer to add fuel. The computer bases fuel delivery on multiple sensors. MAF sensor measures air volume entering the engine. ECT sensor reports engine temperature. The computer uses these inputs to calculate fuel. Faulty sensor data makes the calculation wrong. When you encounter the P0175 code, there is a list of common culprits to investigate. One of the most frequent causes is a faulty fuel injector, stuck partially open, allowing fuel to constantly drip into the intake manifold or cylinder. Poor spray pattern. Fails to close completely after being energized. Since P0175 points to Bank 2, the problem is often isolated to injectors on that side. A single leaking injector can throw off the bank average. Another major suspect is the fuel pressure regulator. The regulator maintains steady pressure in the rail. If it fails closed or restricted, pressure can build beyond spec. High pressure makes every injector spray more fuel per event. On some V engines, each bank has its own rail and regulator, making high pressure a single bank issue. The mass airflow (MAF) sensor is a critical input and common error source. If its delicate wire is contaminated with dirt, oil, or debris, readings become inaccurate. A dirty MAF can report higher airflow than actual. The ECM then enriches fuel to match this phantom air, causing rich. To fix P0175 without wasting money, you must follow a logical diagnostic sequence. First step. Connect a quality scan tool and look at live data, not just the code itself. Observe short-term fuel trim. Observe long-term fuel trim. Check Bank 1, check Bank 2. For P0175, you'll see trims on Bank 2 showing large negative numbers. Example, minus 15%. Example, minus 25%. This shows the ECU is removing fuel. Compare those numbers to Bank 1. If Bank 1 trims are normal, close to 0%, the issue is isolated to Bank 2. Second step, inspect oxygen sensor data for Bank 2. Watch voltage of the upstream sensor, sensor 1. Normal engine. Voltage should rapidly switch. Low, lean around 0.1 volts. High, rich around 0.9 volts. With P0175, you'll likely see voltage stuck high, meaning the sensor detects excess fuel. That doesn't mean the sensor is bad. It's working correctly. Do not replace it now. You look at the freeze frame data associated with the P0175 code. This is a snapshot of sensor readings when the fault triggered. Engine speed, RPM, vehicle speed, engine load, coolant temperature. If the freeze frame shows the code was set at idle, suspect a leaking fuel injector. If it was set under heavy load, suspect fuel pressure regulation under demand. The decision to replace a part should only be made after it has been proven faulty through a controlled vacuum leak on bank 2. The O2 sensor voltage should drop immediately toward 0. If it stays stuck high, even with extra air, the sensor has likely failed. Only then is replacement justified. Contamination. Often, cleaning with dedicated MAF spray restores function. Verify by watching airflow in grams per second on a scan tool. At idle, GS should roughly equal engine displacement in liters, e.g. 3.5 L, 3.5 GS. If GS is drastically high at idle after cleaning and there are no air leaks, the sensor may be electronically faulty. Ultimately, a part is confirmed bad when it fails a specific test against a known spec. Driving your vehicle for an extended period with an active P0175 code is not just bad for your wallet at the gas pump, it can cause significant and expensive damage to other engine components. The continuous presence of excess fuel in the cylinders has a solvent effect. It can wash the protective film of engine oil off the cylinder walls, increasing friction and wear between the piston rings and the cylinder, potentially causing a loss of compression over time. The most immediate and expensive victim of a chronic rich condition is the catalytic converter. When it is constantly flooded with raw, unburned fuel, the unburned fuel ignites inside. Temperatures spike. The ceramic honeycomb can melt, break apart, and clog the exhaust system. A bricked converter. A clogged catalytic converter creates massive exhaust back pressure which chokes the engine. You will notice a severe loss of power, terrible fuel economy, and the engine may struggle to run at all. Replacing a catalytic converter often costs well over $1,000. This expensive repair is a direct consequence of not addressing the initial, much simpler P0175 fault. Fixing a leaking injector for a couple of $100s is far better than replacing a converter for 10 times that amount. In summary, the correct approach to a P0175 code is one of patience and logic. So you have concrete evidence that it has failed. Ignoring a rich condition is a gamble that rarely pays off. It will foul your spark plugs, dilute your oil, damage your engine, and destroy your catalytic converter. Take the code seriously, diagnose it correctly, and fix the root cause.